Okay, here we're gonna graph inequalities, which are different obviously because instead of an equal sign, we have an inequality sign, which means instead of one solution, we have, or like some solutions that fall on the line, we're gonna have an infinite number of solutions that are gonna be like a whole portion of my graph. And in the past, you've done this in one variable, so like x is greater than 7, where you just draw a number line, 7, closed circle, and then you shade in the side of the number line. Now, instead of shading in a side of a number line today, we're gonna shade in a portion of a graph, which would represent the same thing. So what we see is we still have something in slope-intercept form. So I still have a slope of -2/3, and y-intercept here of -1, which I can use to graph in general. So that's what I do. I graph -1, I go down 2/3, down 2/3, and down 2/3, and so on. Now, where this changes is typically we just connect using a solid line, right? But just like how we have closed circles versus open circles, we need to have something similar in two variable inequalities. So here we can have a solid line for equals and a dashed or broken line for not equals. So since this one is just greater than and not equal to, we end up just having a dashed line with breaks in it. So if I make my line from end to end of my graph, and arrows to be safe, I now have my line that represents the inequality, but the problem is I don't show an entire solution set, I just show the line. So in order to show the solution set, we need to figure out which section of the graph has the solutions. In other words, a solution makes the inequality true. So if I wanted to make the inequality true, I need to test if the points on this side of the line or if the points on the other side of the line are the ones that are going to make this inequality true, and it will only be on one side. So what we do is we use a test point. I do not want you just looking at the greater than sign and making an assumption because you might be wrong. So you go to a test point, which we're typically just going to use 0, 0, because the nice thing is that when you plug in 0, 0, things cancel. So we take our test point and we try substituting to see if it's going to be part of our solution set. So if I have y is greater than -2/3, x minus 1, y is 0, x is 0, and then I just do the math. 0 is greater than 0 minus 1, or 0 is greater than -1. So I think to myself, is this true? Is 0 greater than -1? It is. So since it's true, it should be part of my solution, which means I need to shade toward it. True? Towards. So when I think about it, I'm either going to take my pen and I'm going to shade everything on this side, which would be up and to 0, 0, or on this side, which would be down and away from 0, 0. Since it's true, we go toward it, which means I want to go toward 0, 0, or my test point. So I shade the side that has my test point in it to include it in my solution set. Okay? So from here, we'll do one more example, because now I have an entire set of points that could be in my solution. For example, 7, 3 would be a solution because it's in the shaded region. Now, -4, -3 is not a solution because it's not in the shaded region. So if we do another one, here it's a little bit more difficult because I'm not in slope-intercept form. So the first thing I always have to do is move it into slope-intercept form quickly. So that I can use this to graph my actual equation. So from here, I can graph this quickly. 3, my slope is up 1/3. Now, if I have to connect my dots, I have to look at my sign, and this one will be solid because it's equal to, unlike the top one, which was dashed because it wasn't. So from here, I quickly connect the line with a solid line this time. But I'm not done because I still need to do the same thing with my test point to figure out if I'm gonna shade up and away from 0, 0 or down and toward 0, 0 in this case. It's always on either side of my line that I shade. So I use my test point, which is right here, which I label so it's easier to shade later. And I do 3y minus x greater than or equal to 9. 3 times 0 minus 0 greater than or equal to 9 would be 0 is greater than or equal to 9. This one, 0 is not greater than 9, so it's not true. This is false, so we shade away because it's not in my solution set. It's not a true statement. So I look here and I think to myself, which way am I shading? Do I shade up and away or down and toward? And since it was false, I'm gonna go up and away for this one. And now I can find any solution to my system as the points above this line, but not below it. Okay? And this is what will help you tomorrow to get a start with this before we start doing it in context.